Then for force balancing, we can write N is equal to W cos 60 and F is equal to W sin 60. Why these are equated to each other? Because this system is at rest. So overall, these forces has to be equal to each other. So from here, if we want, we can find some relation between normal reaction, force of friction, and there can be many things. So questions usually demand that we should be able to write down equations like this, and then based on what they have given, what they are asking, we can alter. Now, the second case for the same is if it is moving with constant velocity. If it is moving with constant velocity, then forces will be same, but there will be some change in the equation. Can anyone of you tell me that what will be the change in the equation?
Sir, does it matter if it's moving downwards or upwards?
It is moving downward with a constant velocity v. Okay, so now will there be any change in the equation? Forces will be same, but when we have to write down the equation, so will there be any difference? If it is moving with constant velocity, then vertically, if I talk about N and W cos 60, there's no change. So I will just write N is equal to W cos 60. But when it comes to this horizontal one, W sin 60 and F, so since it is moving down, so it means that W sin 60 will be taken first minus force of friction, and since it is moving with constant velocity means acceleration is 0, so that will be equal to 0. What I have written on the left hand side is net force acting on the body. Net force acting on the body is equal to mass into acceleration, that is Newton's second law. So that's why acceleration is 0. It's a constant velocity. And eventually I'll get the same result. W sin 60 is equal to F. So you have to understand this thing that there will be no change in the results, though it is at rest or moving with constant velocity. But
So
last
we
case,
use sine theta for we use sine theta for the y component, right? How do we can you explain how we derive the components when we use them in the free body diagram?
okay, you know what are the components?
Yeah, the x component and the y component.
Yeah. In our last lecture, we did components of vectors, but that was on the coordinate axis. Yeah, so this is the challenge. If the component is not on the coordinate axis, then how do we do it? For example, if we have an inclined plane and this is a force for which we have to write the component. This inclined plane is at an angle of theta. Okay, so in such cases, what we keep in mind is that there are two components. One is in the direction of angle and the other one in the opposite direction. So the component which is in the direction of angle will always be cos theta, and the other one will be sin theta. Other one you need not learn it separately. It's just you can learn like that. Other than the one which is in the direction, it will be sin theta. So in the direction of angle, it will be cos theta. Opposite to that will be sin theta. We cannot visualize x and y axis over here. So similarly, let's say now just to create an illusion, I give angle over here. This is the force. So what will be the components? Like what will be the vertical component in this case? the component in the direction of angle will always be cos theta. So vertical component will be f cos theta and the other one will be sin theta.
So it'll be the opposite of what it usually is.
Yes. So it all depends on angle. What you are considering as a usual case is this, when angle is over here. Okay, so in the direction of angle, it will be f cos theta and the other one is f sin theta. So it is better to learn it like this, that the component in the direction of angle will be cos theta. I'll just write it down. Component in the direction of theta will be f cos theta, while other one will be f sin theta. While other one will be f sin theta. Okay, is there any question over here?
Also.
Okay, so there is third case left. In case number 3, it is moving with a certain acceleration and that acceleration is 2 meters per second square. You have the same diagram, everything is same. This block is moving down with an acceleration of 2 meters per second square. So you need to write down the equation. Okay, so what are the equations? Can anyone tell me first?
The vertical stays the same.
Vertical stays the same, right? For the horizontal one, so n is equal to w cos 60, while since it is moving down, so w sin 60 minus f is equal to mass into acceleration. Net force is equal to mass into acceleration. Intentionally, I wrote this net force in the previous case so that you will get an idea that whenever we have to write, it should be written in this form only. It was a constant velocity. That's why net force was equal to 0. Acceleration was 0. But if there will be an acceleration, then net force is equal to mass into acceleration. We don't have to solve it anymore, but yeah, this is how it was supposed to be done. So if this is clear, we can move on to another question where we have to write first equations and then solve for whatever they ask. So is it done?
Yes, sir.
Ashima, Raghav, done?
Oh, yeah, sir.
Yeah.
Read the question carefully. Try to write down the equations. Rearrange the equations and then you will get one of the option. And that net force is equal to its own mass times acceleration. Now the first question which I have for all of you is, why acceleration of both the blocks are assumed to be same? Raghav, your answer was correct. Do you know the reason?
Not really.
And I hope you are understanding what I was saying looking at your working. We were supposed to write equations like this. Okay? And then from there, we have to get the answer. Ashima and Rishon, any doubt in equation?
Sir,
No,
sir, I got this part, but after here, I'm confused.
Okay. Ashima, you're clear till here?
yes, I made a sign mistake in the plus and minus for mg minus f. I put mg plus f.
Okay. Now, from these two equations, if you observe carefully, we have to find the acceleration. We don't need tension. So this tension needs to be eliminated. In both the equations, it is there with opposite sign. It means you're going to just add them. So 1 plus 2 will get rid of tension and we will be getting mg minus f. On the right hand side, it is ma plus ma. Acceleration will be common and m plus m will be inside the bracket. I need acceleration, so I can send this m plus m on the other side. So mg minus f divided by m plus m, and option C is the correct one. So just look at the equations. A block of mass m rests on a trolley of mass m. Coefficient of dynamic friction between the block and the trolley is mu. A horizontal force F acts on the block, causing it to slide over the trolley. What is the acceleration of the trolley? Okay, so the first thing which all of you needs to understand over here is that since the horizontal external force is acting on the smaller block, so there will be only friction force only which will be responsible for moving the bigger block. If this thing is clear, I can move on with further explanation. Is there anyone having doubt in this? They are asking acceleration of the trolley. Trolley means the bigger mass. So trolley will be moving because of force of friction. So indirectly, they are asking us to calculate friction acting on the bigger one and the smaller one. And that friction which acts on the smaller one as a reaction will move the bigger one also. And that will be the net force acting on the bigger block or the trolley. So if we calculate friction on the smaller one, friction is equal to mu r, or in other words, I can also say that mu mg. And this force of friction is the net force which acts on the trolley. If I talk about trolley, so the net force acting on the trolley will be mu mg, and its mass is capital M, and the acceleration we are trying to find. So from all these, I can get the value of acceleration as mu mg over m, and that's the answer. So more than the calculation and writing, it was first, you should be able to understand that what they are asking. If there's any doubt in that, I can explain again. Okay, so is it done? Shall we move on then?
Yes, sir.
Our next question is, a flower pot of mass 15 kg hangs from two strings attached to the ceiling with tension A and B, where it remains in equilibrium. Derive two equations for A in terms of B. A and B are the forces. They are the tension forces. Give any values to an appropriate number of significant figure. So I'm waiting for you guys to give it a try first.
Like, what was the physics reason behind that?
Horizontal forces will be equated. Horizontally, we have A cos 40 and B cos 60. Since the overall system is in equilibrium, this is an important word because of which we are balancing the forces. So overall system is in equilibrium, so we can balance it out and we can just write net horizontal forces and net vertical forces.
Okay.
In more simpler terms, whenever the system is balanced, so net forces in the x direction are 0 and net forces in the y direction are 0. Net means you have to simply add them, vector sum. So if A is in, let's say, left direction, B is in right direction, so I will write B minus A is equal to 0, and that will give me B is equal to A or A is equal to B. So we never write this B minus A is equal to 0. We rather write B is equal to A. So that's what we did over here. A cos 40 is equal to B cos 60. And the same logic we applied for the second equation also.
Sir, I have a doubt regarding significant figures. So I don't remember the rule for this, but let's say if the number is 0.655, would that become 0.65 or would that be 0.66?
If it is 0.655, then we always check the second last digit. If second last digit is odd, then we can write it down as 0.66. If the second last digit is even, then it will be written as same, like we will not increase the number.
Okay, sir.
Okay, like over here also, when I wrote this 1.35, okay, so in the calculator it was coming out as 1.347. 347 is on the left hand side of 350. Just think like this. So when it needs to be rounded off to two significant figures, then I cannot write it down as 1.4 because it is on the left hand side of 350. Similarly, if this would have been even 1.351, then up to two significant figure, we can write it down as 1.4 because it is on the other side of 350. Like 350 is the mid value. Before 350, it will be 3 only. And after 350, it will be 400. That is 4. So that is why it is written as 1.3. Okay, whenever you are solving any questions on significant figure or if you are revising from anywhere, just observe these things. Okay, there are few rules at this level which can create confusion, but by observing, you can make it clear. Okay, so